Hi everyone, so today we are going to go over compound events. So you just completed a Google Forms on both independent and dependent events. So I want to start by reviewing questions 1 through 3 with you. So remember, for compound events, you're going to have more than one event occurring, okay? And what you want to remember to do is you always want to multiply the probability of the first event by the probability of the second event. So let's look at our first example here. A number cube with faces 1 through 6 is rolled and then a nickel is flipped. What is the probability that an odd number is rolled and the coin lands heads up? So first of all, I'd start by finding the probability that the number cube is going to land on an odd number and the probability that the coin is going to land heads up. So if your number cube has the numbers 1 through 6 on it, your odd numbers are going to be 1, 3, and 5. So there's a total of 3 odd numbers on the number cube. So the probability of rolling an odd number would be 3 out of 6. So that probability is 1/2. For a coin, any coin, the probability that the coin lands heads up would be 1/2. Okay, so now to find the probability that these two events will occur together, we're going to multiply them. So take 1/2 times 1/2, you should get 1/4. For number 2, there's 6 blue marbles, 10 red marbles, and 4 green marbles in a bag. You pick a marble, put it back, that's really important, and then pick a second marble. What is the probability you pick a green marble and then a red marble? So we're going to pick 2 marbles here. We want a green one and then a red one. Now for these types of questions, you really want to make sure that you're paying attention to whether the first item, in this case it's marbles, is put back before the second pick. So they tell us specifically here that we're going to pick one marble, but I'm going to put it back before I pick a second marble. So that's really, really important. This problem has replacement in it, meaning that that first marble is put back. So let's start by finding the probability that you're going to pick green on the first pick. There are a total of 20 marbles. So if you take 6 plus 10 plus 4, you get 20. And then there are 4 green. So the probability of getting green is 4 out of 20. Now, for my second pick, because I'm putting that first marble back, I still have 20 marbles in my bag. So my total is still 20. And on this second pick, I want to get a red. So I have 10 red marbles. So it's going to be 10 over 20. So multiply these together. You get 40, so 4 times 10 is 40, 20 times 20 is 400. Simplify that fraction, you get 1/10. All right, and last but not least, let's look at number 3. Violet's friends are drawing colored tickets at random from a box. The box holds 12 pink, 8 blue, 5 purple, and 7 yellow. So if you add all those up, you will get 32 total tickets. After each pick, the ticket is not returned to the bowl. So up here, we were picking marbles. Before we picked the second marble, we put the first marble back. Here, in this example, we are not putting back the first ticket before we pick a second ticket. So that's really important. There's no replacement here. What is the probability that the first person picks purple and the second person picks yellow? So let's start by finding the probability you're going to pick purple. Typically, this first probability fraction is a little bit easier to find. So the probability of purple, there are 5 purple tickets out of a total of 32. So 5 out of 32. Now, here's where you have to be careful. For this second pick, because I took a ticket and I did not put it back, I only have 31 total tickets in my box. So my total has gone from 32 down to 31. The probability that I'm going to pick yellow then, well, there's still 7 yellow tickets. So I'm going to assume that I picked a purple ticket on the first one and put that aside. So that doesn't influence my yellow tickets at all. There's still 7. So I have 7 out of the remaining 31 tickets that are yellow. Multiply these, and this fraction does come out to be very large, but it does not reduce. You can leave it as 35 over 992.